So, you've decided to learn Python. That's awesome. But you've probably also felt that sinking feeling, right? The excitement is there, but so is this just wall of overwhelming information. Well, don't worry, we're gonna cut right through all that noise and give you a real, practical roadmap. Let's get into it. This question. This is where it all starts, isn't it? You jump on a forum like Reddit and you see this exact post a million times. It's the starting line for so many aspiring programmers, but the answers, man, they can send you down a rabbit hole you might never come out of. And boom, the second you ask, you're just bombarded with suggestions. Now look, these are all amazing resources, seriously. But the problem is, when you're just starting out, having so many options for the best way can just freeze you. It's classic analysis paralysis. You end up spending weeks just picking a tutorial instead of, actually coding. So what's the real first step? Okay, your first real decision comes down to this. There are basically two main schools of thought here. Do you want a structured, step-by-step guide, or do you just want to dive in headfirst and start making something? Let's break this down. On one side, you've got your guided tutorials. Think of this like taking a class. It's structured, it's organized, and you're going to get a really solid foundation. Then on the other side, there's project-based learning. This is more like an apprenticeship. You learn on the job, picking up skills exactly when you need them to build something you actually want to create. And let me tell you, the people in the project-based camp are super passionate about it. This quote from a Redditor just nails that feeling. Their point is you can only watch so many videos before your brain turns to mush. The real learning, the deep learning, that happens when you're in the trenches, trying stuff, breaking stuff, and let's be honest, Googling error messages until you find a fix. But here's the secret sauce. It's not about choosing one over the other. The people who really learn this stuff the fastest, they do both. They use a great tutorial to get the basics down, but, and this is the most important part, as soon as they learn a new concept, they stop the tutorial, they close the book, and they go build a tiny little project with it. That loop of learn, then apply, that's the magic formula. That's what makes it stick. Okay, so you're writing code that runs. It does the thing. That's a huge milestone. But now you've hit the next level of the game. It's not just about writing code that works anymore. Now it's about writing good code. And trust me, there is a world of difference. First up, and maybe the most important pillar, is readability. The whole philosophy of Python is built around this idea. This isn't just about making your code look neat. It's about being kind to your future self. Seriously, when you come back to your own code in 6 months, are you going to have any idea what a variable named KA means? No way. But calculate underscore rectangle area, you know exactly what that does. It's all about clarity. And next up is maintainability. Think of this as future-proofing your work. Good code is like a box of Legos. Each piece has a single clear purpose. Bad code is like a big, tangled ball of yarn. If you need to fix something in the Lego set, you just swap out one brick. Easy. If you try to pull a single thread from that tangled mess, well, the whole thing might just unravel on you. And here are some super practical common mistakes that every beginner makes. I know I did. Like naming your own file math.py. Sounds harmless, right? Wrong. Python gets completely confused and can't find its own built-in math tools. And that weird-looking if underscore name underscore underscore equals underscore underscore main line, that thing is a lifesaver. It basically says, only run this block of code if I'm running this file directly, which lets you safely import its functions into other scripts later on. Dodging these little landmines is a huge step up. So once you've got the hang of writing clean, readable, maintainable code, that's when things get really interesting. A whole new set of power tools becomes available to you. Let's peek ahead at some of the cool stuff on the horizon. Eventually, you're going to want your program to do more than one thing at the same time. Let's break this down simply. Multi-threading? That's best for when your code is just waiting around, like waiting to download a file. It's like having a bunch of cooks, and while one is waiting for water to boil, the others are chopping vegetables. Multiprocessing is different. That's for heavy-duty number crunching. That's like opening up a whole new kitchens, each with its own cook, to get a massive job done faster. And then there's asynco. This is for juggling thousands of tiny network tasks at once, like a popular web server. Think of one superhuman barista handling an insane number of coffee orders without ever breaking a sweat. It's all about picking the right tool for the job. All right, so we've covered what to learn and how to learn it. But there's this one other really annoying problem. how do you actually remember any of it a week from now? Meet your arch nemesis, the forgetting curve. It's a real thing. Our brains are basically wired to dump information they don't think is important. I mean, look at this. Within a single day, you can forget about 70% of what you learned. It's not you, it's just how our brains work. But the good news is, we can hack it. And the way we fight back is with a technique called spaced repetition. It sounds fancy, but the idea is dead simple. You just review something right before your brain is about to delete it. Every time you do that, you're signaling to your brain, hey, this is important, keep it. And that pushes the information from your shaky short-term memory into solid long-term storage. So how does it work in practice? Well, here's a basic schedule you can use. Learn something new today, review it tomorrow, then again in 3 days, then a week later. You see the pattern? The gaps get bigger and bigger. And you don't even have to track this on a calendar. There are apps like Anki that are literally built to automate this whole process for you. It's a total game changer. And that brings us all the way back to the beginning, back to the community. Because let's be real, learning to code can feel pretty lonely sometimes. But it is so, so important to remember that you are not doing this by yourself. Seriously, tapping into the community is like unlocking a superpower. That r/LearnPython subreddit is ground zero for getting help. A lot of the big courses have their own Discord channels where you can team up with other students stuck on the exact same problem as you. Find these places. Find your people. They'll be the ones to pull you through the tough spots and high-five you when you finally get it right. So that's the roadmap. It's pretty straightforward, right? Mix tutorials with projects. Write clean code you can actually understand later. Use spaced repetition so you don't forget everything, and lean on the community when you need help. That's the whole game. You have the map. You have the strategy. But all the advice in the world doesn't mean a thing until you write that first line of code for a project that you actually care about. So the only real question left is, what are you going to build?